I was obviously in a bit of a feisty mood when I named this talk Doomsday Preppers. And I did it because I think the thing that stays in my mind, well, one of the archetypal tales about preservation, is the story of the Doomsday Book and the fact that when it was digitised, it lasted 15 years instead of the 1,000. So, but I thought what I might do is talk about what we're doing towards preservation at UTS, and this is specifically preservation of research data. And it's quite interesting to have heard, well, everybody's talks have been interesting, but I enjoyed Jay's talk because she's coming at it from a very top-down level, and as a research data manager at UTS working with the research team, I'm actually coming at it from more of a bottom-up level, I guess. So I think that hopefully there's some value in looking at it from both sides. My favourite preservation cautionary tale is actually a research data one. This one's really interesting. I still remember in 2013 seeing media headlines about the potential dangers of unbalanced omega-6 oil consumption. And you can see it here in Donald Trump's favourite publication, omega-6 fats linked to increased risk of heart disease. Like most media headlines, the backstory of the actual research paper in BMJ, which you can also see there, actually turned out to be much more complex and actually a lot more interesting too. And that's what the case of the missing data refers to. Basically what happened was a US cardiovascular researcher was doing a meta-analysis and he'd come across this paper from 1973, a research paper, and it was about the Sydney Diet Heart Trial. And the Sydney Diet had been collecting data since the late 60s, and it had hypothesized that, the people who ran the trial, researchers, had hypothesized, according to the lipids hypothesis of the time, that if you replaced saturated oil in the diet with polyunsaturated oil, that this would lead to better cardiovascular outcomes. And unfortunately, that didn't turn out to be the case. The trial actually had to be discontinued because the participants had shown a higher rate of mortality on the intervention than those who were in the control group. Actually, it was by 6 percentage points higher. So when the Sydney researchers wrote up the results, I guess they were pretty embarrassed because, their hypothesis had been disproven. They didn't know why. And they did mention what the polyunsaturated fat was used in the intervention arm of the trial, and it was safflower oil, and that immediately piqued the interest of the cardiovascular researcher who was doing the meta-analysis. And it just so happened that safflower oil, we now know, contains only omega-6 fatty acids, no omega-3s. And the US researcher thought this was quite an interesting outcome and began hunting for the data set. And obviously, he tried to contact the research team. There was only one of them who was still alive. He was really curious to find out what was the cause of mortality in, the greater risk of mortality that happened in the trial. And that's why he needed the data. And so he found the last surviving researcher, and they dug around in the boxes in their garage and produced an obsolete, 9-track tape, which magnetic computer tape it was, and a bit of, digital forensics had to go on in order to recover the data. But it was worth it because it really added to the knowledge of lipid metabolism. And essentially what they found was that the increased mortality was due to cardiovascular and coronary heart disease, a higher incidence of those in the omega-6 intervention arm. So let's remember that this study couldn't actually be replicated without risk to humans. It would have been unethical. So if that data had gone forever, it really would have been gone forever. And I think it's a great cautionary tale because it highlights some of the extra challenges around research data and how do we know what to preserve, because knowledge often does grow in ways that are unpredictable. And so we know under the Records Act that we have to preserve data from human clinical trials for up to 25 years, but in the case of this situation, 25 years would not have been long enough. you can't predict how long it takes for knowledge to reach a different state in which data becomes relevant again. Our records manager suggests to us that it should be up to the researchers. They're the experts, and they should be the people who tell us how long to preserve it for if it requires longer preservation. But in this case, I doubt that the Sydney Heart Diet Study researchers would have actually recommended this data for preservation, because they didn't at the time realise that it was significant. So what do we do? Preserve everything? I think we all know that that's not really viable. It's one thing to keep data and another thing to actually manage it over decades. So I thought that brings me to another challenge which we have with research data, and that is that researchers are not terribly keen to turn over their data to anyone for management often. So we have a big cultural change issue. And it's understandable because that's their competitive advantage. So firstly, maybe we should step back and say, what is research data? And I've got 3 examples up here on this slide. Okay, it can be, here we've got some codes and microscopy slides, which are actually quite big files, and some geospatial data. And research data, that's only 3 examples. Research data really can be just about anything, and that in itself is a bit daunting. So these examples, or at least the last 2, are not human readable, and obviously that means that we need to preserve more than just the research outputs if the data is actually to remain accessible and reusable. Broadly speaking, the usual approach here for us is we try to convert to open formats without losing any metadata. I'm sure you're familiar with that. And we also preference open source software where we can, because we can retain it. So this is where my concept of the fact that we're preparing for preservation sort of comes in. We're not there yet. I think preservation is more of a journey than it is a destination. And we find that we have to start a lot earlier in the data life cycle. Sorry, just went forward. We need to start a lot earlier in the data life cycle than the archiving stage to ensure that metadata and provenance data aren't lost. And this involves a lot of changes to researcher practice. And also it's a big cultural change challenge. And so if we think about the data on this slide, one of the problems we face is that a lot of scientific data coming off instruments, it's in proprietary formats. And the microscopy slide here is quite interesting because it's this is a issue that the microscopy community are looking at, and there's a consortium called the Open Microscopy Environments, or OME, and they're accompanied by Bioformats, which is another arm of them. And they basically bust open the proprietary files from all the optical microscopes and extract all the metadata and the images as pyramidal TIFF files, and then we can import them into their open source platform, which is Omero, which we can see on the slide here. And similarly, the map data that we're showing there is in an open source imaging repository where it's in open standardized formats inside GeoServer. So in both of these cases, these platforms offer significant enough benefits to the researchers that we can actually encourage them. We don't have to work too hard to encourage them to use them. So that's a good thing. Likewise with GitLab, anyone here who's a techie knows that GitHub and Git generally is a really useful repository environment for managing code. But how do we bring all these things together, all these different discipline-specific repositories into one managed solution? Basically, we loosely couple them together in this architecture, which we call Provisioner. And what happens is a researcher who's at the top centre of the slide there, they can actually, at the beginning of a project, access data management solutions, or which we call workspaces, and we can provision those basically they can request and have them provisioned using the provisioner. So we're trying to ensure that the data is under management from the beginning. We can keep track of the metadata and the provenance. And at the end of their projects, they create data records with the necessary metadata. And a lot of that has already been captured along the way. So they can upload their data then or link to it in place, because some of it's very big. Basically, Stash keeps all the various metadata packages we need together. That's our research data catalogue. And we have the metadata that we need to manage, describe, contextualize, and ultimately preserve the data. Well, so basically, if we find additional useful platforms, we'll plug them into this architecture. And so we've sort of covered the difficulties around persuading researchers that keeping their data isn't the same as managing it. The second aspect of it is that sometimes, as you can see in this comment on Cameron Nayland's blog, you know, there's people who want to manage their data, they're already persuaded, but there's actually not the tooling or the easy methods for them to do it. So we're also doing an initiative to try and make archiving easier. And this is the Data Crate initiative. So for the techies in the room, we're running, so Data Crate is basically a new standardisation effort led by UTS to try, and it's specifically for research data. It's based on the Bagot spec, and basically you can add linked data, metadata in JSON-LD format and describe the package, its files and its context, so things like the organisation who funded it and so on, and the equipment used. And basically the plan is that Data Crate will allow us to move data between systems and with rich file level and package level data, metadata, sorry, and also with a human readable manifest so that it contextualizes it for future users. So here's a screenshot. It's using the data site specification to, you know, if there's enough metadata present in the package, it'll produce a data citation that can be used by any future user of the data. So yeah, really essentially data crates are data packages that have a content manifest, checksums and to ensure fixity, and they have metadata from all sorts of sources that we've collected along the way, including package level and file level descriptions of the content. And you can see here that we're picking up on pronom information about the different encoding format and file formats. So I guess what I've been trying to show here is that at UTS, we might be early on the journey to preservation. We've actually got it on the roadmap for next year, and it's been great learning about other people's efforts. But we have been trying to build in some preparation into our systems and thinking so that when we do run our preservation project, we'll have some of the tooling and the metadata there to make that happen. And I'll be happy to answer any questions in the break. And thank you.